Hi, everyone. Welcome to the NVIDIA GTC Studio. My name's Tiffany Jansen, and today I'm joined with Pankaj Sharma, who is the Executive VP of Software and Services at Schneider Electric. Pankaj, welcome.
Thank you, Tiffany.
How's your GTC been going so far?
Excellent. It's been the last 2 days, super busy, a lot of information, but that's really good.
That's really good to hear. You know, when I saw that we'd be having a conversation today, I was really looking forward to it because I think what Schneider Electric is working on and some of the challenges that you are solving are some of the biggest challenges we are frankly facing right now when it comes to AI infrastructure and scaling. And on that note, we are seeing incredible momentum around AI factories. We're seeing a ton of them starting to pop up. But in order for them to be successful, they need a ton of power. Can you share with me a little bit about some of the challenges and also opportunities that brings?
It brings, first of all, a lot of challenges and opportunities. So maybe just take a step back. If you heard the keynote when Jensen was sharing the 5-layered cake.
Yes.
And we play at many layers, obviously, but the primary role we play is at the bottom, where the energy infrastructure has to come in. Now, the challenge at hand is that the utilization and applications of AI are starting to increase dramatically. I mean, we see it in our own lives, right? As consumers or in businesses and how it is making everything more efficient and so on. But to build all of that, you need the AI factories, for which, of course, you need physical infrastructure, and also you need available energy. Now, when we think about the overall planet and the amount of energy available, and we have to keep in mind that at the end of the day, it has to be sustainable too, right? So available energy and green energy availability is overall a challenge. And that's why the big push right now, and when Jensen also shares the bottom layer, it's so important for us to be able to solve for that. So yeah, that's a huge issue at hand. So it's related to grid infrastructures, it's related to clean generation of energy, it's related to availability of physical infrastructure, which is efficient, which is where companies like us come in. So that's the overall challenge. But like you said, it's also a huge opportunity. It's a huge opportunity because while you think about availability of energy, you also have to think about how utilizing AI, you can make the availability of energy better. So at Schneider, for example, what we talk about is AI for energy and energy for AI, right? Everybody talks about energy for AI. Oh, energy, so much of energy needed. But AI can actually enable by simplifying through digital and so on.
Isn't that so funny how it works where it's, you know, we need so much energy for AI and AI is going to be the enabler to solve that challenge at the end of the day. What are some examples of AI being able to do that you have seen, being able to solve some of these grid challenges? Because the grid really isn't set up for this level of scaling when it comes to AI.
Multiple examples I can give you. So one of the examples I'll give you is when you think about in a large data center, right? There's so much of heat getting generated because of compute. So you need to take out the heat, which means you need cooling, and you need cooling systems and HVACs and so on. Just by utilizing AI algorithms on how historically the air conditioning system, HVAC systems are working, we are able to save almost 10% energy being utilized, right? So this is when you turn them on, turn them off, etc. So this is where agentic comes into play, right? I mean, it automates the whole performance. Other examples of where AI can help is, for example, overall in a large data center environment, on the physical layer, you have compute. So when you apply an AI to think about when is compute needed and when it is not needed, let's say in a large training factory, that can then help utilization of energy and bringing the need for energy down. So AI for energy actually is a very important tool. And I try to say that whenever somebody asks me this question, because it's very easy to just get overly perplexed by the fact that, oh, there's so much of energy needed. But unless we do AI, we can't even solve for that. Of course, we need to generate, but we can't solve for what is available and how much is getting utilized.
Yeah. Absolutely. And I think that's on a personal level, I think, to be honest with you, that's where I am currently at in my research journey, if you will, when it comes to AI and the energy required to keep on scaling is I'm in that stuck phase where it's, well, how are we going to solve this? Where is it going to go? So hearing from you of that, those use cases and examples with AI is really exciting, especially that stat 10% for cooling.
Yeah, I mean, there are other examples I'll give you. Like when you think about software, we have one of our businesses which is called the digital grid business, which is how do you optimize the grid? Just by utilizing software on how the grid is managed, you're able to bring down the technical losses by a few percentage points.
Yeah.
Now that means that much of available energy, which can be utilized for all the other things we're trying to do. Now, if you put that in AI, AI helps again, right? So it's almost circular if you think about it.
You know, have you at Schneider been working on this with AI for, I'm curious, because right now I feel like it's a topic of conversation, and I'm sure you've, been bombarded with so many questions around this, but have you been working on this way before, I'm sure, that people were even starting to really think about it, like the general public?
Yeah, and look, the need for energy is something which has been a challenge for many years.
Yeah.
It's not something new, right? The only thing is, because now we have stronger LLMs and we have much stronger compute capability, NVIDIA, the application of AI has become rapidly faster.
Yeah.
So hence the need of energy has gone up dramatically. But the need of energy for data centers has always been a challenge. For a company like us, we look at it from 2 points of view. First, because we create the physical infrastructure, so our goal always is to make it more and more efficient. And efficiency then helps. Efficiency is through design of the product, but efficiency is also through digital, which is how you manage those parts, the entire digital part, the software part of it. So we've always, as a company, been working on bringing out those kind of technologies so that the input energy which is going into a data center and how much is actually getting utilized by compute, you start to reduce that gap dramatically. So that's been an effort of Schneider Electric for a very long time. We've also been focused on thinking about how you utilize that in a sustainable fashion. It's just that today, with the demand going up so much, everything needs to be accelerated, right? So it's not just accelerated compute, it's accelerated generation of energy, it's accelerated infrastructure which is needed, it's accelerated digital, which is all softwares which are going to make it easier. So all of that has to be accelerated.
It really can't be done in silos. It has to be a solution altogether almost.
Exactly. I mean, that's such a good point you're making, because when you also think about the entire build out of an AI factory, each system, each component of the system is important, because you get the best optimization of both the physical layer and the software when it works as a system. So the system play is absolutely critical. So great point.
I know Schneider does both, as you mentioned, the physical aspect, like the physical side of things, and then also the software. Are there any scenarios where you are solving a problem, working with a company who already has one or the other, and even though both are so important, you have to kind of really adjust based on that? So maybe it's an existing AI factory, or they have pretty archaic software that they're dealing with. Are there any cases of that?
So your question really is around, let's say, brownfield,
Yeah.
if you will, right? And I mean, there are not many existing AI factories.
Yeah, that's true. That's
kind of
true.
getting started, but we've been building data centers. The world's been building
Yeah.
data centers for many decades now,
Yeah.
right? And typical utilization levels in data centers are extremely high right now, as you can imagine, because the demand is so high. But some of the builds which happened in the past have reached a limit of performance, simply because they were never built for this level of compute. So we have those kind of examples, and to your point, both on the physical layer and the software which is utilized there. There are times when you can have a brownfield environment and you can apply software. And when we say software, we talk about energy intelligence. And I'll maybe take a second here to explain to you what that means. Energy intelligence is where, when you have performance data of data centers as one example, and any other application for that matter, for the longest period of time, for decades, you utilize that data and then put AI on top of the data with the help of software, come up with insights, which you can either be AI augmented or AI native, more so AI native now, when you heard that as a conversation, so that those insights can help improve the performance of the physical layer, right? Now, in a brownfield environment, sometimes with energy intelligence, this can be done.
Yeah.
The challenge always is, if it is a much older environment, the physical layer is not digital.
Ah, yes.
So either you attach something like an appliance on the physical layer to make it digital to be able to gather the data and perform what I said as energy intelligence, or you really need to swipe it out. So it's a whole process. Like as a company, we do that for our customer. Like, first of all, we have ourselves been building data centers for our customers for many decades now, right? So we work with them to think about their physical layer and do a complete asset analysis, etc. Try to bring in digital software, etc. to simplify. But if there are times there the physical layer is just not digital at all, then all you have to do is you have to swap it out.
Absolutely.
So there are those kind of scenarios.
That's really interesting. It's exciting to me, or interesting to me, because every scenario is so different, and every challenge is. I mean, there's a lot of similarities, but the way you have to think slightly about each one is different.
Yeah, I mean it's different also because it depends on where the data center is located. It depends on the environment around it. It depends on availability of power, how much more power is needed. Like for example, if you're already maxed out on power availability in a certain geographical location, even if you can build more, there is no point of that, right?
Yeah, I didn't think about that. That's a very good point. Why is it important? We kind of spoke about this earlier, but why is it important to manage all of these systems together for AI factories? Can you expand on that a bit more?
Yeah, when you think about an AI factory and when you think about everything that goes into the physical layer, so first of all, you have energy coming in, and even in an AI factory, which by the way is some of the most, let's say, well-utilized environments, also because there's a lot of training which is happening in those AI factories, right? So it's kind of similar type of loads, right? Even in those environments, there is standard capacity of energy, which means if you're getting 100 points of energy coming in, you're utilizing only 64, as an example, for compute, which is the whole point, which means you still have 40, which is standard somewhere.
Yeah.
So that's one example. Then what do you do to make it better? So this is where software, AI, energy intelligence kind of things come into play. The second point is when you think about the physical layer there, so you have different parts of physical layer. So you have the power infrastructure, you have the cooling infrastructure, you have cabling, you have data, you have all of those things, right? So each one of them individually has to be the most efficient, but collectively is where the handovers happen. So as an example, the amount of compute getting generated leads to the utilization of the power infrastructure. And when that's linked to the cooling infrastructure, that handover is absolutely critical. If that handover is not seamless, then you're losing a lot of energy. You talk about the standard capacity, that's where you're losing.
That's crazy.
So that's why the play of the system is absolutely critical, even if each one of those individual components are the most efficient components, software-defined components.
Yes.
But the system play is absolutely critical.
Absolutely. That makes sense. So much energy and heat is lost if it's not, for example, going back to liquid cooling or properly system put in place.
Exactly. So liquid cooling now, of course, I mean, for us is an integral part of what we do, right?
Yes.
When we, about 2 years ago, we had Motivair come in and join our company, and they're the number one leader in the world in that space. But it's important there, not just, so back to the system play, it's not just important to have the best liquid cooling technology from an offer standpoint, with the cooling distribution units or the heat exchangers, etc. It's also important how the flow of fluid is managed inside the data center and at what temperatures it's getting managed. What's the optimum temperature? Because all of that eventually is leading into the amount of energy we are consuming. And if you're wasting energy when you're consuming it, then that's something which makes it inefficient. And again, we're talking about the fact we need more and more and more and more energy, right?
Absolutely. That's such a good point. I never thought of it from that perspective, especially around with liquid cooling. I'm like, oh, liquid cooling, it's going to solve so many problems, but there's so much more that goes into it. Even the way it's flowing, the way it's set up, if it's not done properly, then wasting energy.
Exactly.
There is, throughout our conversation, we've addressed that there is a bottleneck when it comes to AI scaling. And one of those bottlenecks is around power. Other than, for example, liquid cooling, what are some other ways to unlock this?
So liquid cooling is a part of the physical layer, right?
Yeah.
So everything on the physical layer, whether it's power infrastructure, cooling infrastructure, has to become more and more efficient, right? Which is what we spoke about already. On top of that, one way to unlock it now is with the energy intelligence,
Yes.
right? So with energy intelligence, the ability to capture data, to be able to design better. We talk a lot about SimReady in this conference, with NVIDIA. There's a reason for that, right?
Yes.
Because everything which you put in, if it is simulation ready, SimReady is simulation ready, then it's able to do the digital twin, where even before building the AI factory, you have a design which is the most optimum design, right?
Exactly.
So that's why this entire energy intelligence layer comes into play. So now what you can do is you can build a digital twin in advance before you make the AI factory. But with the intelligence of all the years of data which you have in functioning of each one of those offers, those physical layer offers, you create AI algorithms, which tells you how to now build so much better than the way you would have built in the past. So to unlock, to your point, the utilization of energy, it's both on the efficiency of the physical layer, but it's also on the energy intelligence which comes, which is again AI for energy.
I love that. Energy intelligence.
Energy intelligence, yes.
That's one. I learned a lot through this conversation, but that was, for me, that's the take home that
That's what we do. That's what we do. I mean, as a company, if you think about Schneider Electric, again, we've been in the, not just data center, many other businesses, but we're an energy management company.
Yeah.
But more and more energy needed for AI cannot happen without energy intelligence because of the learning what we have collectively for so many decades on how the performance of energy is and utilization is. You have to apply AI on that, and that's energy intelligence. And of course, there are other things. You need more grids, you need better grids, and there are many other things we need to do.
Pankaj, thank you so much for your time today. This was a really insightful conversation.
Thank you.
And thank you all for tuning in. Make sure to go check out more sessions on demand in the GTC catalog.